Last time we have learned what are equipotential surfaces. The surface having same potential at any point on it is known as equipotential surface. So equipotential surfaces due to uniform electric field are going to be parallel planes. These equipotential surfaces are going to be planes which are parallel to each other. So we will write them as parallel planes. These equipotential surfaces are going to be parallel planes. Now, before that we learned equipotential surfaces due to line charge. These are going to be coaxial cylindrical surfaces. You can call them as coaxial. All of them are going to have same axis. And you can call these spheres as concentric spherical equipotential surfaces. Concentric. All these spheres are going to have same center. These cylinders are going to have same axis, and these planes are going to be parallel to each other. We also know that the relation between electric field and potential E bar is equal to minus in the bracket dou V by dou X into I plus dou V by dou Y into Z plus dou V by dou Z into K. This is the relation which we already know. For one dimensional case, we can write this as E bar is equal to, now no need to take the partial derivative, minus dV by dx if it is one dimensional case in x direction. If it is one dimensional case in y direction, you could write this as dV by dy, and for z you can write it as dV by dz, and for any general direction r you can write it as dV by dr also, no problem. One more thing that we should note is the calculation of potential difference. If potential is given as a function of position, by partial derivative you can get field. But what if field is given as a function of position? By integration you can get potential difference. So the total potential difference formula is minus in the bracket integral of E bar dot dx bar plus E bar dot dy bar plus integration E bar dot dz bar. We can solve this and we can ultimately get it. Basic formula is not this. Basically the formula was general formula, integration E bar dot dr bar, where dr is a three-dimensional displacement. You can write this as minus integral of E bar dot dr bar, and then E bar can be replaced as Ex into I, Ey into Z, Ez into K, and this dr bar can be replaced by dxi plus dyz plus dzk, and then you can get it as integral Ex dx after taking the dot product plus, of course, bracket here, integral dy dy plus integral Ez dz. This is what we get for a three-dimensional case. If it is only one-dimensional case, then delta V will be equal to minus integral simply Ex dx for one-dimensional case. Now, What if our electric field is constant? What if our electric field is constant? Suppose it is a one-dimensional case and electric field is constant or uniform over all the positions. Then this E could be taken out of integration. So inside integration we will have this dx. Now integral dx can be written as delta x. So this is the formula we get for uniform electric field. If at all the field is uniform, then the relation becomes Ex is equal to minus delta V by delta x, total potential difference upon total perpendicular distance. Total potential difference upon total perpendicular distance. Okay, this calculation is a result of dot product. So if the field is uniform, you can write this directly. No need to take partial derivative. If the field is uniform, you can take total potential difference upon perpendicular distance. Means, for example, observe this. If these are the two surfaces and this is uniform electric field, in that case you can write, because you know that at all the points the electric field is going to be same, there is no need to find dV by dx. You can directly find total potential difference between these two surfaces. What is total potential difference between these two surfaces? V3 minus V2 upon distance. What is the distance between these two surfaces? Let us say distance between these two surfaces is small r2. Between these two surfaces, let us say it is small r1. Of course you have to measure the perpendicular distance. So for uniform electric field only you can do this. Of course the minus sign is here used for indication of the direction. Minus sign फक्त direction दाखवायसाठी वापरले गेलेले आहे. You can write it like this also. You can forget this minus sign, forget this I cap, forget this bar, and just deal with the numbers. Magnitude. For magnitude, the answer is going to be the potential difference between the two equipotential surfaces upon the distance. So here you can directly write the magnitude of electric field as, now which potential is going to be higher? V2 is going to be higher and V3 is going to be lower. So write the potential difference and write the distance. You will get the magnitude of electric field. The same can be obtained like this also. What is the potential difference here? V1 minus V2. And what is the separation there? Perpendicular distance, not any other. Perpendicular distance is R1. So if the electric field is uniform, you can use this formula. So write with me. For uniform electric field, for uniform electric field, electric field E bar is equal to minus delta V upon delta X. That is, you can directly use the formula of potential difference upon distance. In magnitude, it is going to be E is equal to delta V upon delta X. Potential difference upon perpendicular distance between the two equipotential surfaces. Potential difference between the two equipotential surfaces upon perpendicular distance between the two surfaces. So example will be here, E can be written as V1 minus V2 upon R1, or it can also be written as V2 minus V3 upon R2. It can also be written as V2 minus V3 upon R2. This is applicable only for uniform electric field. This is applicable for uniform electric field only, not in any other case. For any other case, electric field at different points is different. So at each point you have to calculate dV by dx, dV by dx. Every point you will have different value of electric field, not same. है. Now come to the equipotential surfaces due to line charge. This is the equipotential surface due to line charge. What is the electric field at distance, at radial distance r from the uniformly charged line? काय असते electric field? It is K 2 lambda upon r. This is the electric field at radial distance r. This is just the magnitude. Now let us assume the charge is positive. Then electric field will be away. Now the electric field which is away is taken as positive. So this number itself is a positive number, and here plus sign indicates the direction of the electric field is away. Now from this electric field you can figure out what is the potential difference between this surface and this surface. Okay, now how to do that? For that we can write, this is a one dimension, this can be taken as one dimensional case in direction equal in direction r. So you can choose any direction r, let's say this direction or this direction or this direction. You can choose it as any one direction r. We know the potential difference between the 2 points is equal to minus integral E bar dot dr bar. Okay, if we try to solve this, what will we get? Minus integral, let's say this E bar, this is the E bar. At any general point the electric field is going to be away, rightward, and let's say the displacement dr bar is also rightward. Displacement dr bar is also rightward. So for that we can write E bar is equal to, or E bar dot dr bar is equal to magnitude of electric field into magnitude of displacement into cos of angle between them. Because both of them are in same direction, I can take it as cos 0. Let's say initially I am at distance equal to r1 and finally I am going to be at distance equal to r2. Okay, now if I solve this, then what will I get is this E bar is to be replaced as K 2 lambda upon r dr as it is, cos 0 no need to write. So K into 2 lambda outside integration. Inside integration, what is that I have? Limits from r1 to r2. Limits from r1 to r2. Integral of what? Dr upon r. Dr upon r integral means what? Dx upon x. What is integration of dx upon x? Ln x. What is integration of dr upon r? Ln r. So what will be the answer? Minus K 2 lambda ln r, limits from r1 to r2. This is the formula for potential difference between the two surfaces, or between the 2 points which are at distance r1 and r2 from the wire. Okay, so of course no need to remember this derivation, you just write down the formula. Write down delta V is equal to this formula, potential difference between the 2 points. Write down this minus K 2 lambda ln log of upper limit minus log of lower limit is log of upper limit upon lower limit. You can choose the first point as first point at distance equal to r1, second point at distance equal to r2. Here electric field is non-uniform, it changes with the position. For different values of r, electric field is different. So in this case potential difference is this. field is this, minus k2 lambda ln r2 by r1. This is the formula for potential difference between the 2 points on the 2 surfaces. First surface should be at distance r1 and second surface is at distance equal to r2. दोन पॉइंट्स मधला पोटेन्शियल डिफरन्स काढला आपण. आता पोटेन्शियल डिफरन्स आहे लक्षात घ्या, म्हणजे हा लिहिणार कसं तुम्ही, हायर मायनस लोअर, लोअर मायनस हायर असं नाही येते. ते काय आहे, फायनल पॉइंट पोटेन्शियल मायनस इनिशियल पॉइंट पोटेन्शियल असं येते. इथं मायनस साइन एक्स्ट्रा आहेच. इथं मात्र जे केलंय, इथं काय केलेलं आहे, मॅग्निट्यूड काढलेला आहे. इथं काय केलेलं आहे, मॅग्निट्यूड काढलेला आहे. त्यामुळं हायर मायनस लोअर अपॉन डिस्टन्स, हायर मायनस लोअर अपॉन डिस्टन्स. ऍक्च्युअली इथं पण कसं आहे, मायनस ऑफ पोटेन्शियल डिफरन्स अपॉन डिस्टन्स. दिस इज डिफरन्स मीन्स फायनल मायनस इनिशियल. मायनस साइन इथं वापरलेला आहे, इथं वेक्टर आहे सगळं. सो वेक्टरच्या केसमध्ये फॉर्म्युला काय बघा, युनिफॉर्म इलेक्ट्रिक फील्ड साठी ई बार इज इक्वल टू मायनस डेल्टा व्ही बाय डेल्टा एक्स. मॅग्निट्यूडचा विचार केला तर ई बार वगैरे काय घेतलेलं नाहीये. इथं काय करूया वाटलंच तर मॉड टाकूया. जस्ट पुट मॉड हियर ऑल्सो. मॉड टाकला की फक्त नंबर मिळेल. मग काय फायनल मायनस इनिशियल करायचं नाही, हायर मायनस लोअर करायचं. इन दॅट केस यू विल नॉट डू फायनल मायनस इनिशियल. इफ यू वांट जस्ट अ नंबर, जस्ट अ मॅग्निट्यूड, डू हायर मायनस लोअर. If you are using the formula, actual formula, do final minus initial. If you are using magnitude calculation, do not initial minus final, not final minus initial, do higher minus lower. If you are calculating magnitude, this is the rule for uniform electric field. For this, the rule of delta V is different. For this, what is delta V? यातनं delta V काय? इकडनं डेल्टा व्ही काय, युनिफॉर्म इलेक्ट्रिक फील्ड ई बार इंटू डी एक्स, ई बार डॉट डी एक्स बार असं होते ते. किंवा मॅग्निट्यूडच जर पाहिजे असेल, पोटेन्शियल डिफरन्स नाही, मायनस साइनचा पण विचार करू, मायनस ई बार डॉट डी एक्स बार असं डायरेक्टली लिहिता येईल. मायनस ई बार डॉट डी एक्स बार. आणि नंबर म्हणून जर विचार केला तर numerically, if you think numerically, it is going to be magnitude of electric field into the perpendicular distance. Electric field into perpendicular distance. Electric field into perpendicular distance असं होतं. Now every time the direction may not be x, so you can convert this x into better r. या x ला तुम्ही r मध्ये कन्वर्ट करा. Every time direction may not be x, so you can generalize this as r. So convert this x into r. You can also write delta V is equal to minus E bar dot delta R bar or magnitude of electric field into the perpendicular distance. युनिफॉर्म इलेक्ट्रिक फील्ड मध्ये पोटेन्शियल डिफरन्स पाहिजे असेल तर डायरेक्टली हा फॉर्म्युला वापरता येईल. वेक्टर मध्ये हा आणि या डॉट प्रोडक्टला सॉल्व केलं. इफ यू सॉल्व दिस डॉट प्रोडक्ट यू विल डायरेक्टली गेट दिस आन्सर. सिलेंडर साठी काय काय लिहिले होते फॉर्म्युले? E bar is equal to what? Electric field magnitude E is equal to K 2 lambda upon R, and potential difference final minus initial is equal to minus K 2 lambda ln R2 by R1. This is the potential difference between the 2 points for uniformly charged line. This should be V2 minus V1. These are the formulae that you shall remember for line charge. Okay. Now, let us try to solve examples. Solve with me. Example 13. In the following figure, along which path the work done will be maximum in carrying a charge from point A to point B in the presence of another charge? Write down the question. Along which path the work done in carrying the charge, along which path the work done in carrying the charge will be maximum. So you have to carry the charge from point A to point B. So there are different paths. This is the path 1. This one is path 2. This one is path 3. And this one is the path 4. These are the 4 paths. You have to carry a charge Q from point A to point B in the presence of another charge. So this is the charge small q which is to be moved from point A to point B. And this is some other source charge. Which will produce the electric field in this region. And in the electric field of this source charge, you have to move this space charge q from point A to point B. You have to move the point charge small q from point A to point B. Now, this charge capital Q will produce electric field in this region. This source charge will produce in this region some electric field. So you can call this as region of electric field. You have to move the charge Q, small q, from point A to point B. Now while moving charge Q from point A to point B, there is already a force on small q because of capital Q. Why? Because small q is present in the electric field of capital Q. So capital Q will apply force on small q. You have to apply equal and opposite force and on small q, and you have to move it without accelerating from point A to point B through different paths. Now because the electric field or the electric force acting on the small q because of capital Q is a conservative force, the work done by the conservative force or against the conservative force is going to be path independent. So you can write, because electric field is conservative, because electric field is conservative, therefore work done by electric field or against the electric field, that is by external force, work done by electric field or against the electric field is path independent, is path independent. This work is going to be path independent. So in all cases we will be having same work, and if at all you want to calculate work done by the external agent on the charge q in moving it from first point to second point, then you can say work done is equal to change in kinetic energy plus change in potential energy. Now let us say you are moving the charge without acceleration, then work done is simply going to be change in potential energy, and change in potential energy is equal to what? Change in potential energy is equal to final potential energy of the charge minus initial potential energy of the charge. Now you know potential at a given point is equal to potential energy of the test charge upon the test charge. Therefore potential energy can be replaced by potential into charge. Then at final position you can say, at final position you can say potential energy at point B minus potential energy at point A. But what is the formula for potential energy? Potential at a place into your charge, potential at point B into charge minus potential at point A into charge. So it is simply what? Potential at B minus potential at A into charge. So basically it is potential difference into charge. This is the work done by the external force in moving the charge q from first point to second point. आता मला सांगा वर्क डन चा फॉर्म्युला काय आला? पोटेन्शियल डिफरन्स इनटू चार्ज. म्हणजे फॉर्म्युल्यामध्ये फायनल पोटेन्शियल आणि इनिशियल पोटेन्शियल आहे, मध्ये पाथ मॅटर करतोय का? कुठलाही पाथ असू दे, काय लिहायचं आहे? फायनल पोटेन्शियल मायनस इनिशियल पोटेन्शियल. पोटेन्शियल at B point is fixed. Also potential at A point is fixed. A point चं पोटेन्शियल B point चं पोटेन्शियल तर फिक्सच राहणार आहे. The formula comes out to be equal to potential difference into charge. Formula काय आलाय? Potential difference into charge आलाय. What was the formula? Work done by the external force on charge q is equal to change in its kinetic energy plus change in its potential energy. If you do the work without accelerating it, it is simply change in potential energy. You can write it as potential energy at final point minus potential energy at initial point. Potential energy at final point is potential at final point into charge minus potential at initial point into charge. So it is simply what? Potential difference into charge. It is simply going to be potential difference into charge. So what matters is potential difference and not the path. You simply have to write final point potential minus initial point potential, that is potential difference into charge. So path will not matter. That is mathematically proven here. Mathematically पण prove झालं का बघा. Who will produce the potential at this point? Not the test charge, source charge. So work done on your charge is equal to potential difference into your charge. This is the formula. So work is going to be path independent. Next, question number 14. हे लिहिलंय का? वर्क डन चा फॉर्म्युला पोटेन्शियल डिफरन्स इनटू चार्ज असं लिहून टाका. This is work done on small q while moving it from point A to point B. Next, question number 14. A charge 20 microcoulomb is situated at the origin of the xy plane. So draw the coordinate system xy. Show the coordinate system. Then at the origin of the coordinate system, put a charge of 20 microcoulomb. So let us write here small q and write the value of small q as 20 microcoulomb. A charge of 20 microcoulomb is situated at the origin of the xy plane. What will be the potential difference between the points 5, 0 and -3, 4a? Okay. What is asked? Potential difference between the 2 points. What is the first point? 5a, 0. And what is the second point? -3a, 4a. Where will be the 5, 0 point? Here. This is the point A with coordinates 5a, 0. Where should be the point B? -3a and +4a. Not in the third quadrant. It should be in second quadrant. Here. This is the first point. This is the second point. What are the coordinates of second points? -3a, 4a. Write down. And what is asked? Potential difference between them. So final point potential minus initial. Now our source charge is plus q. Our source charge is point charge. This is our source charge. This source charge will produce some potential at point A and it will also produce some potential at point B. So try writing formula for what is asked. How to find potential at point B? Our charge is point charge. Our source charge is point charge. What is potential due to point charge at distance r? What is potential due to point charge at distance r? Potential due to point charge at distance r. Kq upon small r. And electric field Kq upon r square. Field Kq upon r square. Potential Kq upon r. So what shall we write? K is K, Q is Q. Let us call this R as RB. R is RB. Minus potential at point A. Again, our source charge is point charge. From point charge, let us say distance of point A is RA. So what will be the potential at point A? It will be KQ upon RA. K is known, Q is known. What are the problems? RB and RA. So how will you find RB? Call this as equation 1. Now go for finding RB and RA. What will be RB and what will be RA? What will be RA? What will be this distance? Clearly it is 5a, 0 means 5a. And what will be RB? It is -3a and this is 4a. You can use Pythagoras theorem. So it is simply going to be under root -3a square plus 4a square. So that will be 5a square. So that will be again 5a. You can call this as equation 2. Now you can use equation 2 in equation 1. What will be the answer of VB minus V? Hmm. Potential difference is going to be 0. Now you could have directly said that both these points are on equipotential surface. Yes or no? What is the shape of equipotential surface due to point charge? Sphere. They are on same sphere. They are not on different spheres. If they are on different spheres, their potentials will be different. But they are on same sphere. Because they are on same sphere, the potential difference between them is going to be 0. So you could have given the answer directly also, because both of them are on same sphere. Even if I choose point here, potential of C will also be equal to A, equal to B. Even if I choose any other point here, potential of point D will also be same as B, same as C, same as A, because all of them lie on equipotential surface, same equipotential surface. They lie on same sphere. Point charge चे equipotential surfaces कसे असतात? What are the equipotential surfaces of point charge? They are concentric spheres. So you can choose as many points as you want on this sphere. All of them will have same potential. Next question number 15. Solve with me. Question number 15. Electric potential for a point x, y, z is given by y is equal to 4x square. Potential changes only in x direction. Potential changes only in x direction or only with x coordinate. It is not changing with y and z coordinate. So electric field has only x component. What is electric field at point 1, 0, 2? What is asked? Electric field at point 1, 0, 2 equal to question mark. This is easy question. How to find electric field? Minus in the bracket dou v by dou x into I plus dou v by dou y into z plus dou v by dou z into k. But because it is one dimensional case, you can directly write electric field E bar is equal to dv by dx. It's a one dimensional case. Or what you can do, you can find three partial derivatives. Dou v by dou x will be what? Dou by dou x of 4x square. It will be how much? 4 x square derivative 2x, answer will be 8x. Dou v by dou y, it will be dou by dou y of v. What is v? 4x square. While calculating derivative with respect to y, x will be taken as constant. And what is derivative of constant? 0. Similarly, dou v by dou z. What is v? 4x square. While calculating derivative with respect to z, x will be taken as constant. So clearly you can see that. You can call this as equation 1 and you can call this set as equation 2. You can use equation 2 in equation 1 to give the final answer. X into I plus 0z plus 0k. So it is simply minus 8x into I cap. This is the electric field at any general point in the space. But you want electric field at a particular point. What is that particular point? 1, 0, 2. So put x equal to 1, y equal to 0, z equal to 2. So at that particular point, electric field is minus 8 into I cap. So what will be the magnitude of electric field at that point? Magnitude will be 8 volt per meter, and the direction minus I cap म्हणजे leftward. This electric field is uniform or non-uniform? It changes with the position, so it is non-uniform. And what about this? Whether this is uniform or non-uniform? Question is wrong, because at particular point you cannot ask uniform or non-uniform. For general field you can comment as uniform or non-uniform. Hello? Next question. 16. See question number 16. The potential in the xy plane is given as V is equal to 5 in the bracket x square plus xy holds or hold. Find electric field at point 1 comma minus 2. Find electric field at point 1 comma minus 2. Again you can write electric field E bar is equal to minus in the bracket dou V by dou x into I plus dou V by dou y into z plus dou V by dou z into k. All this as equation 1. These three things are unknown. These three partial derivatives are unknown. So partial derivative with respect to x. So you can write this as 5 in the bracket x square plus xy. 5 can be taken out of derivative. Derivative of, okay, after that you have to put the bracket. Derivative of x square with respect to x. Derivative of x square with respect to x will be what? 2x. And derivative of xy with respect to x. Derivative of xy with respect to x. X square derivative will be 2x plus, while calculating derivative of xy, x will be variable, but y taken out of derivative as constant, and x derivative with respect to x is 1. Right now. Similarly, dou v by dou y, dou by dou x of 5 in the bracket x square plus xy, 5 constant outside derivative, x square derivative with respect to not x, y, x square derivative not with respect to x, with respect to y. What is derivative of x square with respect to y? 0 plus derivative of xy with respect to y, x constant outside derivative, y derivative with respect to y will be 1. And partial derivative with respect to z, dou by dou y of 5 in the bracket dou by dou y, dou by dou z. 5 outside derivative, x square derivative with respect to z 0, xy derivative with respect to z is also 0. So overall derivative will be 0. You can call these set of equations as 2, and you can put 2 in 1. Minus in the bracket again in the bracket 10x plus 5y into I cap plus 5x into z cap plus 0 k cap. Plus 0 into k cap. So it will be how much? Electric field at any general point is how much? Minus in the bracket, again in the bracket 10x plus 5y into I cap plus 5x into j cap. Now if at all you want electric field at particular point 1 comma minus 2, 1 comma minus 2, then you will have minus in the bracket, put x equal to 1, y equal to minus 2, x equal to 1 and y equal to minus 2. So in the bracket 10 into 1 is 1, 10 into 1 electric field at particular point minus in the bracket, again in the bracket 10 into 1 plus 5 into minus 2, bracket complete into I cap plus 5x, x is what? 1, bracket complete into z cap and then again bracket complete. See, there are multiple minus signs. So minus in the bracket, again in the bracket 10 minus 10, पहिला ब्रॅकेट काय होतोय व्यवस्थित बघा, पहिला ब्रॅकेट तर 0 होतोय, सो इट बिकम्स 0 into I cap plus 5 into z cap. भरपूर माइनस साइन्स आणि भरपूर ब्रॅकेट आहेत. Do that calculation carefully. So answer is minus 5 j cap. This is electric field at that particular point. At that particular point, magnitude is 5 volt per meter and direction is negative y-axis, along negative y-axis. Minus 5 j cap means 5 and minus j cap. 5 magnitude, minus j cap direction. 5 magnitude and minus j cap direction. You on yourself can put the value of x equal to 1 and y equal to minus 2. Next question. 70. The graph shows variation of potential versus distance. Calculate field at various points. Calculate electric field at various points. Calculate electric field at various points. So we have been given a graph, that is variation of potential as a function of position is given to us. Variation of potential V as a function of position R. So let us choose a direction, any general direction as R instead of X, Y or Z. It's a one-dimensional case. A position is taken as letter R. So the variation of the potential is given like this. First it goes on increasing, then the potential remains constant, and then again it goes on decreasing like this. This is the variation of potential. Plot the points. What is this point? We need only these corner points, okay? Coordinates of this corner points. This point is obviously 0, 0. This point will have x coordinate equal to how much? 2. This point has x coordinate equal to what? 4. And this point has x coordinate equal to 6. This is point A. This is point B. This is point C. This is point O. This potential is measured in volt. And this position is measured in meter. And this is the electric field. No electric field, this is potential. Potential here it is 2. Here it is 1. Okay. So you can write E bar is equal to one dimensional case minus, three dimensional case is minus dou v by dou x, dou v by dou y, dou v by dou z. One dimensional minus dv by dx. But here direction is not x. Here direction is so you can write this dv by dx, but instead of x you will write here into I can. Or because it is one dimensional case, you can simply say yes, still this E bar. Yes, this is still E bar. लिहिताना आपण E लिहितोय, but it is still a vector. Here plus and minus is used to indicate the direction. This E is not the magnitude. This E itself is a vector. Because it is one dimensional case, we are not writing E bar. What is dv by dx? This is y-axis. We made a mistake. What is dv by dr? dv by dx, dv by dr. dv by dx means what? What is graphical meaning of derivative? Geometric meaning of derivative? Slope. This is dv by dx. So for 0 to 2 position, for r equal to 0 to 2 meter, from 0 to 2 meter, the graph is straight line. Graph is straight line, and at all points, straight line has same slope. At all points, straight line will have same slope. So we can say this E is equal to what? Electric field at given point is equal to what? Negative of slope. dv by dx, dy by dx. This is dy by dx format. dv by dr is dy by dx format. So electric field is negative of slope. So for x equal to 0 to x equal to 2 meter, at any position between x is between r equal to 0 to r equal to 2 meter, what is the slope of the graph? It is going to be same. Straight line आहे. Straight line चा slope प्रत्येक point ला काय असणार? Same. So electric field is equal to negative of slope. Slope काढा बरं या ग्राफचा. Slope काय असणार? Straight line चा slope directly काढता येतोय. काय? Change in y upon change in x. Total change in y upon total change in x. Total change in y upon total change in x. इथे काय आलं होतं तुमचा आन्सर इलेक्ट्रिक फील्ड ॲट 1, -2 -5 17 ला ग्राफ काढला होता आपण. It was like this. This point was 2. This point was 2. This was 4. This was 6. Now for one dimensional case, electric field is going to be minus dV by dx, but here direction is not x, so it is r. It can also be written as E is equal to minus dV by dr, but meaning of derivative is slope, so negative of slope is going to be the electric field. So for position r equal to 0 to 2 meter, you are going to have same slope at all the points, so you will have same electric field at all the points. It will be negative of slope. Now if it is a straight line, at all the points slope is going to be same, so you can directly find the slope as change in y upon change in x. So minus in the bracket, change in y means final y minus initial y. What is final y? 2 minus initial y 0 upon change in x. What is final x? 2 minus what is initial x? 0. So what will be the answer? Minus 1 volt per meter, means 1 volt per meter leftward. So it is 1 volt per meter leftward. Direction of electric field या region मधली काय असेल? 1 volt per meter असेल आणि leftward असेल. For position equal to 2 meter to 4 meter, what will be the electric field? Again, it will be negative of slope. Because it is a straight line, you can directly find the slope as change in y upon change in x. Here y is potential and x is distance, so delta v upon delta x. What is change in potential? Change in y. Y मध्ये change किती आहे? What is final y? B points of final y किती आहे? 2. A points of initial y किती आहे? Final y minus initial y. Initially and finally y is same. Initially and finally y is same, or you can directly say it is a horizontal line, so its slope is going to be 0. Or you can waste your time like this. Change in x, final x, initial x. What is final x, initial x? 4 minus 2. So answer is 0. So electric field is 0 at that point. And finally, for r is equal to 4 meter to 6 meter, between the points 4 and 6, for the positions 4 meter to 6 meter, what will be the electric field? It will be again negative of slope, means negative of slope, change in y, total change in y upon total change in x. Straight line ला करता येते असं. No need to find slope at each points. No need to find slope at each point. You can directly find the slope as change in y upon change in x. Final point, final y minus initial y. What is final y? For C point, what is final y? 0 minus what is initial y? 2 upon change in x. What is final x? 6. What is initial x? 4. Answer is going to be minus 2 upon minus 2. Minus in the bracket minus 1 plus 1 येते बघा. बरोबर आहे. Slope is negative, so minus slope will be positive. Yes, for this line slope is negative, so minus slope will be positive. So plus 1 चं meaning काय आलं? 1 volt per meter rightward. So final conclusion can be this: if I want to plot the electric field E as a function of position, then the graph will look like this. For 0 to 2 meter, what is the electric field? 1 volt per meter leftward, or directly you can say minus 1 volt per meter. Minus 1. For all these points, electric field is minus 1, means 1 leftward. For 2 to 4, it is 0. For 2 to 4, it is 0. And for 4 to 6, 4 to 6, it is plus 1. 4 to 6, it is plus 1. So draw this as a graph. So field will be given, potential will be given and field will be asked. Potential will be given and field will be asked. Negative field means leftward field. Then this is zero field. Yes, when potential is constant, its derivative is going to be 0. Means field is going to be 0. Here potential is increasing. Here potential is constant. Here potential is decreasing. If potential is constant, field is 0. If it is increasing, field will be there. If it is decreasing, field will be there. But if the potential is constant, field will be 0. So from the potential graph, you can find field graph. Potential graph will be given to you and field graph will be asked to you. Potential graph will be given to you and field graph will be asked to you. सगळे पॉइंट्स कळले का बघा आजचे? Now we know how to deal with questions of field and potential. Field will be given to you, potential difference will be asked to you, or potential will be asked to you, or sometimes potential will be given to you, field will be asked to you. Sometimes graph will be given to you, and sometimes equation of potential will be given to you. For one dimensional case, generally they will give you the graph of potential and they will be asking you the graph of field. Potential चा ग्राफ दिला जाईल, field चा ग्राफ विचारला जाईल. So अशा टाइप ने तुम्हाला हे सगळे क्वेश्चंस यायला पाहिजे. ठीक आहे? सीबीएसई वाल्यांनी होमवर्क चेक करून घेतला का? अजून कोण कोण राहिले बघा. कोण राहिले अजून चेक करायचं होमवर्क? आज कंप्लीट सगळ्यांचं चेकिंग व्हायला पाहिजे. स्टेट वाल्यांना आजही काय होमवर्क नसेल. उद्यापासून मात्र होमवर्क असेल. आपल्याला होमवर्क मध्ये काय काय करायचं आहे? सॉल्व एक्झाम्पल्स, क्वेश्चन सेट, नीटचे पीवायक्यूज आणि जेई पीवायक्यूज. एक एक स्टेप सगळ्यांनी आता ऍडिशनल काम करायला चालू करा. हे करून अजून एखादं पुस्तक द्या सर आम्हाला, आम्ही ते पण करतो, असं कोण आहे? कोण आहे का? सांगा, त्यांना पुस्तक देणार आहे मी. सर आमची तयारी आहे, आमच्याकडे एवढा डेली वेळ शिल्लक राहत नसेल, थांबू अजून महिनाभर. राहतोय का वेळ? कोण आहे का असं? अजून एक पुस्तक द्या सर, ते पण आम्ही पहिल्यापासून सॉल्व करत. काय रिव्हिजन होत राहते. तुम्ही पीवायक्यूज करायला लागलेलाच आहे, त्यातनं तुमची रिव्हिजन चालूच आहे. अनेक रिव्हिजन करायची आहे सर आम्हाला, साइड बाय साइड. जेवढे बुक्स तेवढ्या रिव्हिजन्स होती. पण ते घेतलं की रोज करावं लागेल. ठीक आहे, असू दे. जेईच्या मुलांना मात्र मी ऍडव्हान्सचं पुस्तक दिलेलं आहे आता. म्हणजे ते पण तुमच्या एवढंच काम करतायत. सॉल्व एक्झाम्पल करतायत, क्वेश्चन सेट करतायत, जेईचे पीवायक्यू करतायत, एचसीव्ही करतायत. जसं तुम्ही नीटचे पीवायक्यू आणि जेईचे पीवायक्यू करताय, तसं त्यांनी जेईचे पीवायक्यूज आणि एचसीव्ही करायचं आहे. ते सोडून ऍडिशनल काम पण त्यांना जर कोणाला करायचं असेल तर ते आता ऍडव्हान्सचं मटेरियल सॉल्व करतायत. तसं तुम्हाला पण जर काय करायचं असेल तर मग एक ऍडिशनल बुक मी तुम्हाला देईन. अलग लक्षात सॉल्व्ह करत जायचं. जेव्हा डाऊट सेशन असेल तेव्हा डाऊट बघू आपण. डाऊट कशी सॉल्व्ह करायची ती काय मोठी गोष्ट नाहीये, ती सॉल्व्ह करता येईल आपल्याला. पहिला तुम्ही सॉल्विंग केलं पाहिजे. तुम्हाला रोज तेवढा वेळ शिल्लक राहिला पाहिजे. रोज 2 नंतर तुम्ही पर्टिक्युलरली सेल्फ स्टडीला चालू केलं पाहिजे. सेल्फ स्टडी म्हणजेच टीचरनी दिलेला होमवर्क जो आहे ते काम करायला तुम्ही चालू केलं पाहिजे. माझ्या हिशोबानं साधारणपणे प्रत्येक सब्जेक्टला आता दुपारी 2 वाजल्यानंतर रात्री 12-1 वाजेपर्यंत तुमच्याकडे वेळ आहे किंवा सकाळी उठून वेळ आहे. साधारणपणे 2 ते 2.5 तास, 2 तास पण नाही, आता 2.5 तास प्रत्येक सब्जेक्टला तुम्हाला देता आला पाहिजे. येतोय का बघा. ऑफकोर्स टीचर्सना पण आपण हे सांगू की 2 नंतर पर्टिक्युलरली शिकवू नका. 2 नंतर आम्हाला पूर्णपणे अभ्यासाला वेळ द्या. 2 नंतर तुम्ही बघा 3 वाजेपर्यंत जेवणार आहे की 10 मिनिटात जेवणार आहे. मटेरियल बुक्स तुम्हाला सगळं देऊ, सगळा सपोर्ट करू, पण सॉल्विंग तुम्ही केल्याशिवाय त्याला काही मिनिंग नाहीये. डाऊट्स पण सॉल्व्ह करू. मला सगळे क्वेश्चन्स येतात. येत नसते तर कशाला दिलं असतं पुस्तक तुम्हाला. एक 15 दिवसानं परत विचारेन, आठवण करा मला. 2.5 तास डेली प्रत्येक सब्जेक्टला मिळतोय का बघा. 2 नंतर आपलं टीचिंग 2 वाजेपर्यंतच असेल. लिहून होतंय ना साइड बाय साइड माझ्या बरोबर.